Good Monday morning or afternoon, depending on when you're watching this. Okay, Miss Coombs, if you could right now have the paper people. There's two paper people in each class. If my paper handlers can now should be on the right table over here that way. If you're well, actually, if you're looking at the screen, it's gonna be that way. Is that right? No, it's going to be that way. I don't know. But over there, there's a table, and it says Lesson 12.1 Notes. If my paper people can take those out and pass those out right now, that would be great. Shouldn't hear voices. Shouldn't be any talking. Should be normal as usual. Thank you so much. Again, shouldn't hear voices at all. Miss Coombs, if you would not mind, just simply hit pause on this until we get all those out, and then feel free to come back over here and hit play. Okay, so I assume that we hit play now and then we're back. Everyone has this. So let's go ahead and begin. This is lesson 12.1 Notes, the Pythagorean Theorem. Now, Pythagorean Theorem shouldn't be anything new to anyone in here. You should have had some prior knowledge from Mr. Doyle last year. I don't know if he still does that, but he normally teaches the Pythagorean Theorem. Pretty easy concept. He ties in some of his content into it. Again, pretty easy stuff. It actually worked out well that it happened to be during this week when I'm off, because I think this is going to be a pretty easy lesson for you all to get. We're probably going to take a little bit further than what you learned last year, but for the most part, we should be pretty good. So make sure you go ahead and put your name on this, just in case you were to lose it. My name is Mr. IPOC. Period. This could be anywhere from 1 through 8, I guess, depending on your period with me. Okay, cool. The Pythagorean Theorem. In a right triangle, the two sides that form the right angle are these are going to be known as the legs. Okay? In a right triangle, the two sides that form the right angle are the legs. The side opposite the right angle is going to be known as the hypotenuse. Go ahead and write that in. Okay. Now we're going to go ahead and let's go ahead and label this triangle what it is. So in a right triangle, the two sides that form the right angle. So this angle and this forms the right angle. So this would be a leg, and this would be a leg. And then obviously our diagonal, or the opposite. Notice this is opposite the right angle, which is right here. This is the hypotenuse. Okay? Cool. Now let's just throw out a key fact. Okay, let's go ahead and put a star right here. This is very important. The longest side is always the hypotenuse. This will definitely come in handy in other lessons, but it's always important for you to understand that the longest side is the hypotenuse. Okay? Alright, so in order to find the length of a missing side of a triangle, you can use the Pythagorean Theorem. I'm wondering if anyone in here could possibly remember the Pythagorean Theorem. Go ahead and shout it out if you do right now. Go. Nope, you're wrong. No, I'm just kidding. Actually, I don't know what you said, because I am literally sitting here looking at an empty desk, and you guys aren't here because I'm recording this on Sunday night, and no one's here except me. Okay, but if you said a squared plus b squared equals c squared, you were right. Okay. Just a little golf clap to those that got that right. Muy bien, very good. Okay, a squared plus b squared equals c squared. Now it's important for us to understand. Let's go ahead and label what most triangles will be. The legs will always be RA, and the other leg will always be the B. Now students get this confused all the time. Well, can this leg right here be A and that one be B? Of course, it doesn't matter. Okay. If it's a leg, just keep in mind the legs are A and B, and the hypotenuse will always be C. The side opposite the right angle will always be the C. Okay. Now this is where dealing with what we dealt with at the beginning of the year, especially with some squares. This will definitely help you out a ton. Okay. So let's not waste any time. Let's go ahead and jump straight into number 1. Looking at number 1, Looking at this right here, notice the triangle is kind of looking a little weird or to the side. Okay, so what I always want you to do first, so I'm just going to write some steps right here. Always do this first. Always identify A, B, and C. Okay. Eventually, we will get away from this, okay? But for right now, we need to identify A, B, and C for each problem. So, let's identify A, B, and C for number 1, okay? So, notice, always find, look at right here, we have our right angle, okay? We have this line and this side. Notice these are going to represent legs. Now, what do we say legs were? Legs were A and legs were B, right? So, therefore, we have an A and a B. So, we have A, we could say 4, or we could say 3, right? Because they are interchangeable, okay? This could be A, this could be A, this could be B, this could be B. It doesn't matter because they're both the same thing. They're both legs, okay? But if A is 4, then that therefore makes B 3. Okay, and then the question is, what is C, this long line right here? So therefore, we don't have the hypotenuse, so we're just going to put a question mark because that is actually what we are looking for. Okay, so now, always after that, after you identify A, B, and C, your second step, you will always rewrite, I know some of you are going to enjoy this, rewrite the formula. Miss Coombs, don't let them whine and complain. They're going to rewrite the formula. Okay, always rewrite the formula. So what is that formula, class? A squared plus B squared equals C squared. I hope you all said that with me. If not, or I'm just sure you're probably looking at the screen like a bunch of bums. The bums you are. I'm just kidding. You're not really bums. It's just what your mom said. Oh, gosh. I'm spitting jokes and nobody's even in the room. That's how awesome I am. Okay, forgive me. I'm sorry. That was a little uncalled for. Okay, so now this is our formula. Now the Pythagorean Theorem allows us to find any missing side of any right triangle. Okay, so it's given us the legs. So now we have A, B, and C. So let's substitute. That word substitute. Let's substitute these values in here. So A is 4. So I got 4 squared equals, what's B? B is 3 squared equals C squared. Why didn't I substitute a value in for C? Because that's what I'm looking for. I want to find the hypotenuse right here. Okay? So let's go ahead and simplify this even further. We got 4 squared plus 3 squared equals C squared. What is 4 squared? 4 times 4 is what? Someone say it. 16. Very good. Plus 3 squared. What is 3 squared? 3 times 3 is 9. Very good. I heard you back there. Good. And then what we have left is just simply C squared. Okay. Now we simplify this even further. 16 plus 9 is what? 26. No, sorry. It's 25, right? Okay, just making sure. 25 equals C squared. Now this is where we're really gonna access some prior knowledge. Most of you may remember what we did here when we have a C squared. Notice, our main objective with any equation is to isolate the variable. Okay, isolate the variable. If you notice here, the variable is not isolated. It has a square on it. So we have to ask ourselves, what in the world is the inverse of square? Raise your hand right now if you know it. Raise your hand if you know the inverse of square. There should be at least 7 or 8 people raise their hand. The inverse of square is to simply square root. And what I do to one side, I must do to the other. Look, I am your father. Sorry. I'm doing a lot of stuff that's extremely uncalled for. Please forgive me, Miss Coombs. Miss Coombs may never come back. Okay, so stick with me. I got a square root and a square. Well, since they are inverse, we're simply going to cancel those, giving me C equals. Now, what the question is, what is the square root of 25? Well, the square root of 25 is simply 5. Okay? So, our hypotenuse here is 5. Okay? But don't forget your units here. So, we're simply just going to say x is equal to 5 centimeters, and we're going to circle this right here. x is equal to 5 centimeters. Now, I know a lot of you are saying, hey, Mr. Alpok, you said anytime we do a square root, it needs to be plus or minus, but just keep in mind, we're dealing with measurement here. I don't think anybody right now could go and be like, hey, can you give me negative 5 centimeters? Go measure out negative 5 centimeters. I don't think anybody in here could do that. So you don't have to worry about that. Tanner, quit talking. Okay. All right, continuing on. Number 2. So looking at number 2, we're going to go on from number 1 and go to number 2. So looking at number 2. Okay. So, and oh yeah, after we rewrite the formula, our third step will just simply be to substitute the values into equation, and then fourth and final would just simply be to solve. Okay, make sure you solve. So substitute the values into the equations and then simply solve. We kind of did that all at once. Again, this shouldn't be anything new to any of you in here. If it is, the Lord have mercy on your soul. Okay, all right, let's go to number 2 now. Look at number 2. Let's see what we have here. We have a triangle, a right triangle, or it appears to be a right triangle because it has this right here. First thing we got to do, identify A, B, and C. So I'm going to write here to the side, write A, B, and C. Okay? And we're going to identify what each of those are. Okay? Now notice here, we have the right angle right here. Now the two sides that form this are known as the legs. Okay? Alright, so it looks like we have one leg, but we don't have the other. That person must work at IHOP. I'm just kidding. That was a really bad joke. I don't know. I'm sorry. You get it. They only have one leg. Okay. Some of you still don't get it. We'll work on it. Okay. All right. But let's just say this is our A. This is our B, and then obviously opposite of the right angle will be the C. So could this be B and that be A? Yes, absolutely, but it doesn't make a difference. Okay. So let's go with A. A is 12. B is question mark, and C is 13. Okay, so after looking at this, we're going to always rewrite the formula. The very second step is to rewrite the formula. We've identified A, B, and C. Now let's rewrite the formula. So the formula is A squared plus B squared equals C squared. I know it's annoying, but I want to see it every single time. Okay, every single time I want to see that happening. Okay, so let's go ahead and substitute these values in. So for A, we have 12 squared. So we say 12 squared plus, do we know what B is? No, we don't know what B is. So B is just simply going to be B squared equals, what is C? C is 13. So 13 squared. Okay, from there we continue. 12 squared is 144. So this is the fourth and final we're solving. Plus B squared, we don't know, equals 13 squared. Now, some of you should know this extremely well, but some of you probably will not. That's completely okay. We'll just act like you know. 13 squared is what? Someone say it. Go. Very good. 169. Okay? Now, notice what we have here. If you look at number 1, when we had A and B and we're looking for C, the like terms were here. But notice here we have a like term here and a like term here. So I'm going to isolate, I'm going to try to isolate this B squared. So I'm going to do the inverse operation of addition, which is subtraction. And I'm going to subtract 144. That gets it to 0 on this side, but what I do to one side, I must do to the other. This cancels. I got B squared is equal to 169 minus 144 is 25. Hey, what do you know? Another 25. Interesting. This is very interesting. Maybe it's a conspiracy. B squared. So is B isolated? Absolutely not. It has a square on it. So I ask you one question. What is the inverse of squaring? The inverse of squaring is to square root. And what I do to one side, I must do to the other. The square root and the square, they cancel. B equals the square root of 25. Can someone say it for me real quick? 5. Very good, very good. B equals 45, so this leg. So I'm going to come up here and say X is equal to 5 inches. Very good. X is equal to 5 inches. Okay. I'm really looking for, I'm not necessarily concerned with you circling this one. Just make sure you circle this, just showing me that this side is equal to 5 inches. Okay. You may say, what's a way for me to check this? This is actually pretty simple to check because now that you have A, B, and C, just substitute it in and both sides should equal each other if you are correct. Okay. All right, going to number 3. Looking at number 3, we will just work, we'll do one more of these and then we'll go to the back side real quick. 3. So look at this. Always first, I want to identify A, B, and C. So I'm going to write down A, B, C, A, B, C. It's easy as one. All right, sorry. I'm having major issues. I'm actually extremely pumped that my daughter's being born in the morning. My nerves are kind of on edge, so I'm a little pumped. Yeah, a little pumped. Okay, so let's identify A, B, and C. Look what we have here. We have, keep in mind, the two sides, this side and this side, the two sides that form the right angle are the legs. We have a leg here. We don't have a leg here. Okay, so either one can be A and B. They can be interchangeable. This can be B, that can be A, that can be A, that can be B. I'm just going to say this is A, which makes this B, and this C. Okay, so let's identify. A is equal to 6. B is equal to, we don't know, and C is equal to 10. Okay. So when you're looking at that, always rewrite the formula. A squared plus B squared equals C squared. Okay. So A squared equals C squared. A squared plus B squared equals C squared. So now let's substitute our values in. A, we have 6 squared plus, we don't know B. B is a question mark. That's what we're looking for. This formula allows us to find any missing side of a right triangle. Okay, that's what that formula does. So, and then what C? C is 10 squared. Okay. So 6 squared plus B squared equals 10 squared. So looking at this, what is 6 squared? 6 squared is 36 plus B squared equals 10 squared is 100. Okay. Again, our objective of any equations is to isolate the variable, okay? Right now, that variable is not isolated, so we need to isolate it. So what I want to do is to isolate B squared, so I need to do the inverse operation of addition, which is subtraction, and subtract 36 from both sides. I got B squared is equal to 64, okay? Oh, I'm finished, right? No, I'm not finished. I have this square, and that means this is not totally isolated. So I need to isolate this variable. The inverse of squaring is the square root. And what I do once, I got to do the other. So B equals, square root of 64 is 8. So then we're going to come here and say just X equals 8 inches. Okay, and that's 3 problems, guys. That's pretty simple so far. Let's go to the back side. Oh yeah, great job to those of you that worked ahead and did that. Joke's on you. Okay, so go to the back side. Looking at, or here, let me just make sure you guys get done because obviously you can't tell me if you're done or not. So let's just make sure you get done with that. So we will look at. Let's go ahead and look at number 5 on the back side. Once we look at number 5. I don't know if we'll have to do another one or not. I think we're kind of getting the point. So let's go ahead and look at 5. Okay. First thing we need to do is to identify. Let's switch the markers up a little bit. Identify A, B, and C. Can't really go with the royal blue colors right now, so we'll just go with the baby blue. I'm still a little salty over Saturday's loss to that state up north. I'm not even going to mention their name. Their name's not even worthy of mentioning. Oh gosh, I'm in a bad mood now. Man, I'm in a bad mood now. I shouldn't have even said anything about it. Man, I hate this blue marker. I'm not even using the blue marker. I don't even want anything close to the blue. All right, let's just go with this purple one. That seems like a pretty legit one. I don't even want to see the blue on my paper right now. A equals, B equals, C equals. Sorry, guys. It's just, did I use any blue over here? No, I didn't. Okay. All right, sorry. Oh, great. Now it looks like cotton candy. I can't. I mean, I don't know. All right, sorry. I'm having a mental breakdown right now just for the simple fact of I had the thought of Kentucky losing to that team up north. Um, my. Okay, identify A, B, and C. The two sides that form the right angle are known as the legs. So we have a leg here and a leg here. So we can say this is, let's switch it up. Let's say this is A, this is B. Could this be B and that be A? Absolutely. Therefore, making this C. Okay? Now, here is my, let's go ahead and identify what we have. Do we have A? No, that's our question mark. That's what we're looking for. Do we have B? That's 13.7. And do we have C? C is 14.8. Okay? Very good. Now, let's go ahead and rewrite the formula. We always rewrite the formula. A squared plus B squared equals C squared. Okay? Now that we've written the formula, let's go ahead and substitute these values in. We do not have A squared, so it remains A squared plus 13.7 or gosh, I said 13.7 squared. I got a little ahead of myself there. 13.7 squared equals 14.8 squared. Okay, and it'd probably be most appropriate to put those in parentheses so there's not a confusion over what's squared or anything. Okay, so now let's go ahead and we say A squared. So when we're looking at this, the question is, you all obviously do not know what 13.7 squared is off your top of your head. Of course I do. It's 187.69. But you need to actually work that out on a piece of paper, something like that. Due to the time sake of the video, I'll go ahead and just write this out to be 187.69. And then, of course, 14.8, probably another number you all don't know off the top of your head, but luckily I do. It's 219 and 4/100. Okay? So then from there, we are going to actually subtract, from there, we're looking for A squared. So what we're going to do is we are simply going to isolate this right here. So we say, what do we say here? Subtract 187.69 from both sides in order to isolate the variable from both sides. So this cancels here, and we have A squared is equal to, it'd be about 31.35. You guys can check my math if you want, but due to time's sake, we got to kind of hurry. Now, from here, we are going to isolate the variable by doing the inverse operation of squaring, which is to square root. The square root and the square cancel. I'm left with, and I'm going to round this, okay? I'm going to round this to 31. So if you get here, just round this to 31. So A equals the square root of 31. You're saying, why in the world did you not give the, why didn't you come up with, the whole number? Well, the square root of 31 is an irrational number, okay? But most of you may remember how to, how to get this into a decimal. If you can remember, that's great. But the square root of 31, a way that you should be able to remember to do this, I'm going to come up here. The square root of 31. Remember, think of what perfect square root is below it. Square root of 25. What square root is above it? 36, right? And we just simply say square root, that's 6. This is 5. Square root of that is 5. So the middle, 25, which is closer, 36 or 25 to 31? Well, 25 is 6 numbers away from 31. 36 is 5. So I would say approximately, A is approximately 5.6. So we're going to come here and say X. X is approximately 5.6 what? Feet. Okay? Alright, cool. Alright, don't worry about the rest of these. Okay, and I think that's it for lesson 12.1. So right now, what we're going to do, paper people, you're going to pass out 12.1. This is 12.1. 12.1 homework. Guys, make sure you do it all. You're going to hit some of those problems that have decimals, okay? I want to see your work, all right? Obviously, I'm not there to judge you at your home, whether you're using a calculator or not. But just keep in mind, whenever you get this number, let's just round that number here, and then let's approximate it to our best ability like we know how, Okay. Again, I'm not, there standing over your shoulder whether you're doing this. Now, there's no calculators in my class. Okay, so if you want to use a calculator, you may have to use that at your home or something like that. Feel free to just do all the work out on your paper if you need to. Hey, I hope this helps for the remainder class. My paper people, you guys are you're gonna get 12.1 homework and you're gonna pass it out to everybody. Everybody, I fully expect you. I fully expect you to be sitting there working. You're not out of your seat. You're not goofing off, acting like a ding dong. You're simply acting like a mature 8th grader, showing respect to me and my time off, and as well as to Miss Coombs. Thank you so much, and I am out of here. Peace.